All right, so me and Ty are back on the 2018 Hyundai Tucson, going over the ignition system. First of all, we started by just pulling one of the coils on the spark plugs. Just get a little deeper inspection. As you can see, the plug isn't too bad. It's a little dirty, and if you smell it, it does smell a little bit like gas, showing that the vehicle would be running rich. That would most likely be due to all of our lab vehicles only being started, cold started and ran for short periods of time, never letting it properly warm up and burn all the contaminants off. And then we have the coil pack out. As you can see, it's in pretty good condition. As the vehicle doesn't have too high of mileage, and I would assume a lot of its runtime has been inside. It does smell a little sweet, a little bit like gas. We'll go into a little bit more what that means. Throughout the rest of the system, everything else seems to be in pretty good shape. All the wires don't really have any damage, and the three other sets are consistent with the first set that we pulled as well.
All right, so we're measuring resistance right now on the primary coil, and I'm getting about 0.9 to 1 ohm, just bouncing back to 0.8. But if you go over the computer, our primary coil resistance is 0.75 plus or minus 15% when it's cold.
All right, so we got our leads now connected to our spark plug, measuring the resistance. As you can see, it's about 3.7, 3.8 kilo ohms. And according to the presentation, that is going to be around specification, as it's supposed to be around 3,000 to 5,000.
All right, so our spark plug gap, you can see right here, just above 0.04. And our specification right here shows that we are within spec.
All right, so looking at our plugs, you can see that it is a 2-wire system, showing that somewhere within the vehicle is going to be the ignition module. So we did actually find a diagram showing how the coil packs are controlled. As you can see, they are routed directly to the ECM.
All right, so me and Bailey are doing a test right now on AM radio to see if we can hear the fuel injectors clicking at all, but we aren't really able to hear it, as you can tell. But with windows coming up, you kind of can hear a little difference. I'll turn it up for you. Not really easy to tell in the video, but makes almost like a little whining frequency noise.
All right, so with that test, that actually goes to show that there is some sort of resistance within the wires for the ignition circuit. That is partially for that reason, to help dampen any unwanted frequencies, so stop it from interfering with either any other systems or with just the radio itself. So if someone had like any form of race car, they might have some less insulated copper wiring. That would be so there is adequate power flow through those wires, because they don't have systems. They usually don't have systems like the radio to worry about. But if you were to do that radio test, the whining that we previously described may be a lot more prominent and noticeable. All right, so we have the spark plug out. As you can see, it's an NGK plug with the model name on it. We went ahead and looked it up on NGK's website. You can see that it is an iridium plug with a platinum ground, and they actually do have a resistance value on here, which is going to be about 5,000 ohms, which is around what we were experiencing. And then for the heat range, that is going to be a 7. That is me a little bit, pretty much kind of in the middle, but a little bit on the warmer side for that. And then for the torque specs, it is going to be about 10.8 to 18 foot-pounds. All right, we just have a little diagram with the spark plug heat ranges. As you can see, NGK's goes from about 10 on the colder side to 5 on the hotter side. So like I said, that 7 will be pretty much right in the middle.
I was going to show you the porcelain, but we already put the spark plug back in. But the porcelain is pretty much just used as a material to keep the heat down. And you can also see, we can't really see right now, but there is a porcelain insert right on the tip where the electro would be, and then also on the back on the other side of the hex.
All right, so we have the picoscope connected to the ignition coil. And then we do have the attenuator on for any voltage spikes. And then here, because the attenuator is on, it's me fractions of the actual voltage shown. But this line should be the 12 volt. And then as it saturates, it drops down. And then when that is switched off, the voltage spikes. And then this section here is going to be the on time for the spark plug.
All right, so we're back. We got the Pico pulled up. 21.79 milliseconds is going to be our on time, and then right here we got these little like oscillations, almost is what you could call them, as like a signal rebound almost.